All right, the second unit was all about normal curves and how a data value relates to a population. All right, let's get into it. So the very first one here is, what are some important measurements or things that you would need in order to label this curve fully? Okay, one of the things that you should know is that the mean always goes in the middle. All right, another thing that we should be comfortable with at this point is knowing that there are 3 standard deviations away on the curve till there is very little area remaining. And so there would be your representation of very little area beyond this way. Very little area, very little area. You don't need to actually label those on there, but just be cognizant of there's hardly anything to do with it. So another question I would have for you is, well, how much area is on the curve or underneath the curve? Or how much percent of the data is under the curve? And the area under the curve is always equal to 1. Okay? Another thing, depending on the context of the problem, if they were asking you to solve for something, not only would you want to label your curve like you already have, but you would probably want to put a title, because what this curve is representing is some sort of population with a whole bunch of data underneath of it. So much so that you just have to collect it with this line. Okay? And if we were asking a question like how much area is beyond this point, some other things you would want to label is find out what this area is. You would want to put your x value, your z-score, and not just your z-score for that, but your z-scores for all the other numbers as well. So just future reference of how we kind of describe things. Again, before we started all of this, we thought it was very helpful to learn the empirical rule, and sometimes the the empirical rule helps you to make references about how much data is underneath a given spot. And so, do you remember what the empirical rule was? The empirical rule said between 1 standard deviation away, everything in here, the area takes up 68%. Versus if you were 2 standard deviations away, all of the area under the curve, all of this included, would end up being 95% of the data. And then if you were 3 standard deviations away, I'm looking underneath the curve, all of the area between those points would be about 99.7% of all of the data. Okay, now that you just remember that those are in the top of your mind, let's see if we can actually answer some of these questions. I highlighted a couple of problems that I think would be very helpful from your packet to be able to answer. I picked number 5, number 7, and then number 9. So let's check this one out. Number 5, on your packet, if you want to fill it out. It tells us that the WISC scores are normally distributed, and it gives me a mean and a standard deviation. Without thinking, I am going to go put my mean in the middle, and then I'm going to put the standard deviations on as well. So 1 standard deviation away would be 115, 2 would be 130, and 3 would be 145. And then if we go in the negative direction, it would be 85, 70, and 55. And again, what is this curve representing? It's representing, if I gave myself a title, WISC scores for different children, what they could take home. And each person in here, or whatever, would be a person with a score on this test, or whatever we're looking at. Okay, so from here, the question, let's read the question. The question says, what percent of the population will have scores above 140? Figure out what we got going on. So again, I would probably go find where 140 is. That's somewhere in here. And I want to figure out the probability of being above that. And so I need to go find this area. And I know that this is recommending, or we're marking off 140. From here, normally we start with your raw data values. From there, in order to figure out what the area is, you have got to take time and find the z-score. The z-score is like your bridge between the two of them. And so I need to go find the z-score for this. And in order to do that, we're going to use the formula. I would also like to put the z-scores on for everything else to give us reference. Because we could take every data value and turn it into a z-score and have a plot in z-scores. Okay, what is the formula to find z-scores? And you have to remember this, and this is something people forget. It's x minus mu of x over sigma of x. Our z, we're just going to plug in things here. We know we have our x value of 40, our mean was 100, and our standard deviation is 15. And if you type that on into your calculator, you will end up getting a z-score of 2.667. Again, that makes sense for where it is at in the data, 2.667, because it's between 2 and 3. That checks out. So now, in order to go find the area, we have started with the normal data. We've used the z-scores. We get to go to your calculator. And in your calculator, you're going to do normal CDF. Jeez, this thing is being silly. So if you go to your calculator, and then we go, let me get out of this. Maybe I won't. You can go, I actually don't know where it's at. Second bars, that's what it is. Second bars, normal CDF. And then you can just type in, ooh, I don't want that. Let's try again. Second bars, normal CDF. From here, we're going to type in our lower z-score. It would be 2.667. And then our upper is positive infinity, because the curve keeps going. And if you click enter, it'll give you your area. Your area beyond there was 0. Smartboard's really off. 0.038 was what we just got from the calculator, but the calculator doesn't like me. And to answer the question, which I've kind of run out of space, what percent of the population have scores above 140? I would say about, it's not going to work, about, if I move my decimal places over, about 38.38% of the data, or of the population, had a score over 140. And you should be able to know how to do that. Okay, here's another one that I feel is like of importance. It is the opposite. It's working its way backwards. So still the same mean, so I'm still going to put that in the middle, 100. Still the same standard deviation. I'm going to throw those ones on there again, 115, 130, 140, 85, 70, and 55. Those are still the same. This time, if we go and actually read, and this is still, I'm going to put the title on there, still about WISC scores for all the people that take that. Down here, the question says, what would a score have to be where 30% of the population is below it? So right now, I'm working with an area. They're telling me the area needs to be 30%. And I need to find the location where 30% would actually be. So in this case, instead of going from your data to a z-score to an area, this time we're actually going to go backwards. We're starting with an area, we're going to find the z-score, and then we're going to go to the data value. And again, we're actually going to start by picking up the calculator first. So, if you go to your calculator, we need to register a couple of things. First off, this time, since we're going in the opposite direction or the inverse direction, when we go second bars, we're going to pick inverse one. So we're going the opposite direction. We want an area of 0.3, and we wanted it to be to the left. And so when we hit paste, it should pop up with that is your z-score. That is your z-score. And again, I haven't quite labeled all the other z-scores on here, but here would be a z-score of 1, or 0, 1, 2, 3, negative 1, negative 2, negative 3. We're going to want to label that z-score on here. And so our z-score was at negative negative 0.524. And we need to find whatever x value goes with that. Okay, so we can kind of see where it fits in. We can see that this is all the area we're talking about. And now we need to work our way backwards more. So we used the calculator to help us find the area. We just found the z-score from the calculator. And now we're going to use the z-score to help us get the data value, our data. So over here, the z-score formula is still x minus the mean over the standard deviation. This time I actually know what the z-score is. The z-score is 0.524. I don't know what x is. That's what I'm looking for, the data value. I know the mean is 100, and I know the standard deviation is 15. And then I'm going to erase this because I'm running out of room. But from here, we can finish by multiplying by 15 on both sides. And when I multiply by 15 on both sides, these will cancel out, and then I'll have something a little bit different, and then I'll end up after that being able to add the 100, and after all of that jazz is over, we'll end up with 92.934. And again, that makes sense if you come back and look on the table. That is between 85 and 100. That kind of checks out, and so we're good with that. And now you would just want to answer the question. What score would have 30% of the population below it? Oh gosh, sorry. Ugh. Just throwing the speakers around casually. My bad. I would say that if you got a score of 92 or below, I don't like the way I worded that. If you got a score of 92 or below, 30%. No. If you got a score of 92, 30% of the population is below you. Kind of weirded strangely, but I think you kind of get the point. Alright, and then last but not least, so you had one where you used a normal CDF, you had one when you did inverse norm, you went backwards, and this one is a little bit different, so let's check this one out on your path as well. Number 9. Number 9, find the proportion of members who fall between two different numbers. So here we have, this time, a mean of 82, so that's going in the middle. And then they tell us the standard deviation is 2.5. So put your third standard deviation on, and then fill in the others. And then we're going to add 2.5 each. So this plus 2.5 is 84.5. 84.5 plus 2.5 is 87. And this would be 89.5. And then if we went the other direction, this would be 79.5, 77, and 74.5. Cool. Alright, we want to find the area, or the proportion of people in this population. It doesn't give us any context, so we can't really give it a title. That is between 82, which is right here. No, sorry, I'm reading the wrong part of the problem. Between 79, which is going to be somewhere right here, and 83. So 83 would be somewhere. And we want to know how much or what percent of the population is jazzes. So that is what we're on the hunt for. So they gave us our data values, and so now we need to find our z-scores. And so let's find the z-score. It's x minus the mean over the standard deviation. We are going to do it for the first one. The first one would be 79 minus 82 over 2.5. And the other one, if we did a z-score, would be 83 minus 82 over 2.5. And then if we actually found the z-scores for both of them, one of the z-scores would come out to negative 1.2, and the other one would come out to be 0.4. And again, those are pretty reasonable looking at this. If we put the other ones, the z-scores for everything, this would be a z-score of 1, 0, 1, 2, 3, negative 1, negative 2, negative 3. This one was negative 1.2, which is right beyond there. That makes sense. And this one is 0.4. Again, that makes sense for that minus 12. And then in order to actually find the area, now you get to use your z-scores on your calculator. So if you went to your calculator, this time we would start by doing second bars, and then we would do normal CDF, because we're looking for an area. This time our z-scores would be from negative, you have to use that negative and not this, negative 1.2 to my upper part I shaded was at 0.4, and then leave everything the same, and that would give you an area of about, let's say this on top of here, 0.5404. And again, to answer the question, which we really have not done, I would say 54.04% of the population is between 79 and 83. And that's it for Unit 2. Again, if you know how to go and use normal CDF, and you know how to use inverse norm, and you can do between two things, I believe you are good to go.